Okay, hi everyone. The reason why we stream data is because it's faster, and it's so fast because we can analyze the data before it even hits the disk, before even it gets stored in any kind of database or file. Reading from the disk incurs more latency than reading from the RAM, but all of this comes at a cost. We're bounded to the total amount of data we can put on the RAM. So good afternoon, everyone. I'm Pol Jane. I work as a cloud engineer in Netherlands here in Barcelona, and today we're going to talk about streaming data. Here are a couple of services that we offer to our customers all around the world. For streaming data, there are a lot of different technologies to enable this. We have several customers using, for example, Kafka, as you know, but for the purpose of today, we're going to be focused on Kinesis and its data set of services. So this is what we're going to be talking in the next 30 to 40 minutes. Hopefully at the end we're going to have some time for Q&A, and I think we've got a couple of mics, so feel free to ask whatever you want. So this is going to be our journey. We're going to talk about real-time decision making. We're going to talk about why we stream data. And we're also going to talk about the value of this data and how it loses its value over time. We're going to talk, I'm going to do a small brief about what is streaming data, just to be sure that everyone here is on the same page regarding to streaming. Then we're going to have an introduction to Amazon Kinesis and its set of services, and also I'm going to talk about event stream processing and how it works, kind of a definition. Then we're going to have an interactive demo. I'm going to need your help, and I hope it works because everything is live. And then we're going to dip a little bit more inside consumers. We're going to talk about consumers, about producers, different ways to consume and produce data into Kinesis data streams. And I'm going to introduce you the new feature presented in August 2018, last year, by Amazon Web Services of the Enhancement of Consumers. Yeah, its pros and cons and how it works. So let's talk about the value of data and how this data loses value quickly over time. This is why we stream data. This is the reason. On this chart, and it comes from Forrester, its author's name is Mike Galliani. And it comes from a paper called Perishable Insights, where he talks about the insights in our data are perishable, meaning its value decays or diminishes over time. So on the left side, we have what we call time-critical decisions. Those time-critical decisions usually occur in milliseconds, seconds, or minutes. Sometimes seconds or minutes is fast enough for a use case, but it's going to be dependent on your application. But it can still be considered a critical data piece. On the right side, we find the traditional batch processing or business intelligence, those kind of data, that historical data that you may use or you may have, that still has a lot of value, but not to make a time-critical decision. Very simple example, and most probably of you have experienced it since you got to Barcelona. You swipe your credit card somewhere, and you got an immediate text message or push notification in your phone from your credit card provider, right? They have some time of real-time analysis happening there. All the transactions are monitored and analyzed looking for fraudulent activity. So they might say, for example, oh, your card has been swiped in this ATM just to get a bunch of cash, or on this restaurant, whatever it might be. And you receive this notification, so they alert you. If it was you, everything is good. If it wasn't you, they want to know, obviously, because they want to take care of it. Sorry. Okay, and that's a real-time decision that they want to know. But they still do batch processing, right? They still send you at the end of the month this bill with whatever was charged in your credit card, and you have to pay it. But they could wait until the end of the month and send you all the for example, 10 of these 100 transactions, 3 of them look anomalous, and you can go on the website and take a look to all the transactions, which is good and which is bad, but that's not good for them, and that's not good for you. So the much important thing for them is to make that decision as soon as the data, it gets created. And how we do that? Through streaming, meaning ingesting the data as soon as it gets created, processing that data on the fly in real time, and doing some kind of analytics, doing some kind of machine learning, maybe triggering some alert at some point, and doing some actions as soon as you learn something from that data. This whole thing is what we call streaming data. Who can remember that time when we were taking data from our applications and putting into a database, and we didn't do any learnings from that data until a process run that night at the end of the day, or maybe a process run at the end of the week to move all that data to a data warehouse and maybe run some reports there. Probably most of you can raise a hand and say, yeah, we used to do that, or we still do that. But to get real-time insights, it's important to analyze the data as soon as it gets created. Most common uses of streaming, I'm not going to talk about in detail about them all, but the most popular we see here, for example, are log analytics, feeding into data lakes, maybe industrial automation, and IoT analytics or IoT devices. I'm going to generalize. I'm not going to call an IoT device like it doesn't necessarily have to be a pressure sensor or a temperature sensor. I would call an IoT device a connected device, like your smartphone, for example. Again, running in your phone, sending data all the time, always sending data. Those 3 on the right, or those 4, they generate a ton of real-time analysis, real-time information. And in the industrial automation, for example, there are a lot of customers using Kinesis. Imagine if they want to know if one of their production lines is stopped or is taking too long to deliver some product. They want to know right away and go and fix it. So how we do that with in AWS? We have 4 different ways to do that. Maybe a quick show of hands. How many of you are using Kinesis data streams in production? Okay. I'm not going to give you a ton of details about all the features and how it works, but I'm going to give you some differences between, and we might choose between one or the other. The one on the left side, Amazon Kinesis video streams, enables you to ingest binary encoded time series data, meaning audio, video, LiDAR, radar, and several other formats. And the other 3 on the right is it's called a data set of services. These kind of services are the ones who can ingest unencoded or encoded data from your systems. It can be log data, it can be application event data, whatever. So those 3 on the right, they all can work together. First of all, we're going to talk about Kinesis data streams. Basically, Kinesis data streams typically requires you to write custom code to get all the data out of the stream. So, for example, you have your data producer, which is putting data into the stream. The data is going to be sitting there for the default period, which is 24 hours. It can be up to 7 days. And then when that window expires, the data is gone from the stream. Then we have our consumers taking the data out of the stream and doing something with it. So in that context, the stream acts like a buffer. It's different than a queue. It's not an SQS. When you pop a message off the queue, that message cannot be longer consumed by any other data consumer, right? Compared to Kinesis Data Firehose, it's very similar. I mean, the front end, the way how you put the data into the stream is very similar, but there are some differences. Actually, there's a big difference. Okay. Let's say you have an agent, maybe running in your local host, which is taking logs from a machine, for example, and sending it to Firehose. Or maybe you're using the SDK. Just a note, for the purpose of today and the features we're going to discuss, I suggest you to use the latest version of the SDK, because some of these features are not in the previous versions. So maybe you're sending direct message by using the SDK into Firehose, but the big difference here is that Firehose has a completely managed consumer. So it can persist the data in S3, in Splunk, in Redshift, or in Amazon Elasticsearch service. So when you ask yourself, I just want to stream data, but I don't want to do much with it, at least not yet. I just want to put my data into S3 and have some kind of durable store and relatively inexpensive spot to put my data. You should consider Firehose, because it's going to be the easiest way and probably the cheapest one. And then we have one of my favorites, data analytics. This last service on your right gives you the capability to do real-time analysis on that data, as we say, before it even persists in any destination. So you can run SQL queries, you can write custom code to say, for example, tell me how many times this event has occurred in the past 2 hours. An example can be an e-commerce or a marketplace that use Kinesis data analytics to find out what the top selling products are in a kind of a 30 minutes window, for example. They stream all the orders data to KDS. They run data analytics to extract those insights from that data. And they can send all this information to a dashboard where the business people, for example, can say, okay, we want to put this product higher on the sales rank. And they can do decisions in that 30 minutes time window. Okay, we're going to dip inside a little bit more in detail, but before, I'm going to need your help. Let's do a quick, fast demo. Just pull up your phones, try to scan the code, and just, if you don't have any application to scan the code, you can just type the URL. I tried to find the easiest one. What you're going to see in your smartphones is kind of a quadrant with 4 letters, and just a point in the middle that you can move, just moving your hand with your phone. I should have a dashboard over there. Okay, here we go. Okay, what you're seeing is all happening in real time. Actually, you're doing this, guys. For example, here we're getting some insights about how many people is on the B, on the C quadrant, or on the D. Let's try to move everyone into the A. It's going to take 1 or 2 seconds. Okay, I'm not going to worry about the delay. I'm not going to worry. This happens all the time. Okay. We have a couple of non-conformers. I say A. Okay. So this can be your metrics. This can be your KPI business. This can be wherever you want. We have a couple of more insights, like, for example, device usage, the unique visitors, total visitors up there, and the different percentage of everyone in each quadrant. So more or less, that's it. We're getting that data instantly from your phones. That data is getting into the buffer. Kinesis data streams is triggering a Lambda function, and this Lambda function is putting that data into a DynamoDB database. I'm going to show you the architecture of this. Okay, I'm not going to talk later in detail about the infrastructure. Actually, it's quite simple, just a demo. But the main point here is that everything is serverless. We're not using any EC2 instance to do that. As you can see, it's only Kinesis, Lambda function, DynamoDB, and of course some S3 bucket to store all the HTML and JavaScript. Okay, but we're here to talk about high performance streaming. So before that, I would like to make some points here, because we're going to talk about producers, but mainly we're going to talk about consumers today. So we have different ways to put data into a stream and different ways to get that data from the stream. As I said before, these last features released by Amazon last year are only available in the new API and the SDK. But as far as I know, lately Apache Storm and Spark also can benefit from these features, and hopefully in a couple of weeks, months, all the other applications we see here and many more. So standard consumers. This is what the vast majority of AWS customers are using nowadays, basically because there was no other way to do that until now. So what is a standard consumer? Before entering into that, just take a look at the white rectangle on the middle. That's a representation of a stream, and it's made of shards. If you're not familiar with shards, shard is a unit of scale in stream. So every shard can get 1 megabyte per second or 1,000 records per second per shard. So when you do an analysis and you have to determine how much data you want to ingest into that stream, that's going to determine how many shards you need to put in that stream. For example, if your use case says that you're going to send 4,000 records per second, you're going to need 4 shards to do that. A consumer application has multiple threads. Each thread gets data from a shard via a get records call on the API. Sorry. And yeah, also this is abstracted by if we're using the KCL library, or if we're using Lambda. If you type code your consumer, you're going to be taking care of that. So what's going on here? The get records call is made and the data is returned. And the get records call can only be made 5 times per second per shard. Also, that's a limitation and it cannot be changed. It's just an AWS limitation. Also, the data cannot be pulled from the stream to the consumer faster than 2 megabytes per second per shard. So that gives us that if we have, for example, a consumer application, the records can only be retrieved every 200 milliseconds. This is a polling operation that your consumer application has to implement, or the KCL will do it for you on your behalf. If you go beyond that, for example, polling at 100 milliseconds, which is 10 times per, you're going to be throttled and probably you will have to back off and retry again. But what if we do that? What if we put 5 consumers taking data from 1 shard and doing the get records operation? As we have the 2 megabyte per consumer per shard, here we have a limitation. So each consumer can only get now 400 kilobytes per second. So what's going to happen? Our latency is going to go up, and probably that means problems for almost everyone. So with the new version of enhanced fan-out consumers, the scenario changed drastically, actually. And they have some new features that can, with the new API, that can solve the previous issues. What's happening with these new enhanced fan-out consumers? As the subtitle says, the big difference here is that the consumers do not pull the messages from the stream. Instead, the information or the data are pushed from the server to the consumers. This is made by using HTTP2. The consumer initiates the subscribe to shard API call. This is how he starts the communication, and this can be up to 5 minutes connection. And it works like WebSockets. How many of you are familiar with WebSockets? Almost everyone, great. So it does almost the same. It's not WebSockets, but it works the same way. It's managed by the protocol itself. It's not a layer on the top of HTTP 1.1. So now the server can send data out of order to the consumer without having to be asked for each packet all the time. That curly brace is our piece of data coming in. The shard will persist it and will send it to the consumer application right away. So, and it's going to continue doing that again over and over and over. So our consumer is going to be receiving data quite often, up to 50 milliseconds to 7 milliseconds. That's the great improvement of this new fan-out consumers. Actually, it's quite fast. Contrasting with the previous case on the get records called, which was 200 to 300 milliseconds, I think that's much better. So the other big benefit is that we don't have any more, each consumer application gets a dedicated 2 megabytes per second egress per shard. So it means that we don't have any more this 2 megabyte contention. When the consumer application says the register stream consumer, we create internally this pipe, this airflow pipe, that gives us that dedicated throughput. So the consumer application has a dedicated throughput of 2 megabytes per second per each consumer. That means that we can put more and more consumers in consuming data from that shard. So the data will be pushed into the consumers and they can get the full throughput. When to choose between enhanced fan-out consumers and the standard consumers? Well, if your consumer application has less than 3, in this case, if you have less than 3 consumer applications, and important, if your consumer applications are not latency sensitive, then you can use standard consumers. Also, it's going to minimize the cost, so I think everybody loves to save money. When you need real-time analysis, and you have multiple consumer applications for the same Kinesis data stream, there is a default limit of 5 registered consumer applications in the AWS, but more can be supported just asking to AWS to increase that limit. And if you have, of course, low latency requirements, it's going to be a little bit more expensive, but it goes quite fast. As you see, it's less than 70 milliseconds. So about event stream processing, just kind of a definition, an event is anything that can happen at a clearly defined time. I'm going to show you some example of a domain event extracted from, I think, one of our customers. All these events have some information like activity, when this activity has occurred, its location, and probably the cause. So this is an example. I think it comes from a marketplace or something like that. We have some product, a Sony PlayStation, some images, all the attributes and all the information, maybe some timestamps. So the stream is a different stream, different kinds of a stream. We have business transactions like customer orders, invoices, bank deposits, information reports like social media, weather reports, or things that we usually see nowadays, and GPS-based location as an IoT data, SCADA systems, and everything. So processing is the final act of putting all this together and getting some real insights, maybe finding hidden patterns, maybe preventing event correlation, and all that amazing things that we can do just analyzing the data before it's going to be stored in any destination. So when we will need event stream processing, I wanted to remove this slide because the events you want to track are happening frequently and close together in time, but actually you can stream everything, so you can find hidden patterns that don't necessarily have to be close in time. And the event, of course, need to be detected and responded quickly. We were talking before about fraud detection, e-commerce, and cybersecurity. Nowadays, we are using security tools that are able to discover patterns or behaviors from an attacker. This IP, which was scanning our systems, it has the same behavior as this other IP scanning this other system, and they do that quite fast. So what challenge we can solve with event source processing? We can analyze high-velocity big data where it's still in motion, and that allows us to process massive amounts of streaming events. So we can respond in real time to changing market conditions. If we continuously monitor data and interactions, we can scale accordingly to the volume or to the traffic we're having in that moment. And that will turn us into an agile company. I mean, we can handle issues as they arise as quick as possible. And also, again, detecting interesting relationships and patterns. So as a recap, data is not a piece of data in a database anymore, since the data set is changing. So that gives us a new kind of dimension regarding to streaming data. So I think data is one of the most valuable assets that a modern company can have nowadays. Thank you.